Let us look at another example of sequencing n jobs on two machines. There are 10 jobs to be processed through two machines, M1 and M2, in the order M1, M2. So basically, there are these 10 jobs which have to go through M1 and then M2, and the order in which they have to be processed on these machines is that first they have to be processed on M1 and then they can be processed on machine M2. Now the processing time required by each job, which is in hours, is given in the table below. Find the optimal sequence for the performance of these jobs in the minimum possible time. So basically we have been given the processing time for processing these jobs on each of these two machines, and this time has been given in hours. Now we have to find out what is the ideal or the optimal sequence in which these jobs should be processed on these machines so that the overall time is minimized. So let us understand this example in a little more detail. Let's say this is machine M1 and this is machine M2. Now let us find out the in and out time for these jobs to be processed on M1 and M2, assuming that we are processing these jobs in this sequence. That is, we'll first process A, then B, then C, then D, then E, and so on. So for M1 we'll have in and out, and for M2 also we'll have in and out. Now let us first take job A. So A needs 2 hours to be processed on M1. So let's say it goes in at the 0th instance and it will take 2 hours to be processed on M1. So it comes out after 2 hours. Now while M1 is busy processing A, M2 is idle. So as soon as A comes out of M1, it can go in to M2. So at the second hour it can go into M2, and then it will take 7 hours to be processed on M2. So this will be out on the 9th hour. Next we'll process B. So B takes 5 hours on M1. So after A has been processed on M1, B can start processing on M1. So this can go in on the second hour, and because it takes 5 hours, this will come out of M1 after 7 hours. Now even though B is out on the 7th hour of M1, M2 is still processing till the 9th hour. So M2 can take B only after the 9th hour, and then it takes 3 hours to process B on M2. So 9 plus 3 is 12. So B will come out of M2 after 12 hours. Next, let's process C. So C takes 1 hour to be processed on M1. Now as soon as M1 is done with processing B, which is at the 7th hour, then C can be processed on M1. So this will go in on the 7th hour, and will come out after 8 hours because it takes 1 hour to be processed on M1. Now even though C is out of M1 after 8 hours, M2 is still processing B till the 12th hour. So C can be processed on M2 after 12 hours, and then it takes 4 hours to be processed on M2. So 12 plus 4 is 16. So it will come out after 16 hours. Next we'll process D. So D takes 6 hours on M1. So it can be started after 8 hours, and 8 plus 6 is 14, so it will be out after 14 hours. Now while D is out of M1 after 14 hours, M2 is still processing till the 16th hour. So D can be processed after the 16th hour. So 16, and then D takes 7 hours to be processed on M2. So 16 plus 7, which is 23. So it will come out of M2 after 23 hours. Next we'll process E. Now E can be started on M1 after the 14th hour, and E takes 2 hours to be processed on M1. So 14th hour it is in, and then 14 plus 2, 16th hour it is out. Now on M2 it will be processed after the 23rd hour, and it takes 8 hours to be processed on M2. So 23 and 23 plus 8 is 31. Next we'll process F. So F can go into M1 after 16 hours, and F takes 3 hours to be processed on M1. So 16 plus 3 is 19. Now even though F is out of M1 on the 19th hour, M2 is still processing E. So F can go into M2 after the 31st hour, and then F takes 9 hours to be processed on M2. So 31 plus 9 is 40. Now G takes 5 hours to be processed on M1. So G will go into M1 at the 19th hour, and it takes 5 hours. So 19 plus 5 is 24. However, G can go into M2 only after the 40th hour. So 40, and G takes 10 hours to be processed on M2. So 40 plus 10 is 50. Next is H. H take 1 hour to be processed on M1. So H goes into M1 at the 24th hour, comes out the 25th hour, and H can go into M2 at the 50th hour, and it takes 2 hours there, so it will come out at the 52nd hour. Next is I. So I can go in on the 25th hour, and I takes 6 hours to be processed on M1. So 25 plus 6 is 31. And then it can go into M2 at the 52nd hour, and I takes 1 hour to be processed on M2. So 52 plus 1 is 53. Next will be J. So let's process J. Now J can go into M1 at the 31st hour, and it will take 8 hours. So 31 plus 8 is 39, and J can go into M2 after 53 hours, and it will take 5 hours to be processed there. So 53 plus 5 is 58. So at the 58th hour, all the jobs will be processed on both M1 and M2. Now the point to be noted is that there is a wait time for some of these jobs while moving from M1 to M2. For example, job B is waiting for 2 hours, that is 9 minus 7. Job C is waiting for 4 hours. Job D is waiting for 2 hours. Job E is waiting for 23 minus 16, which is 7 hours. F is waiting for 31 minus 19, which is 12 hours, and so on. So the question is, can we sequence these jobs in a different way so that the wait time reduces and thereby this overall processing time minimizes? So this is the information that has been provided to us in this example. So we have jobs A, B, C, D, E, F, G, H, I, and J, and we have two machines, M1 and M2, and we have been provided the processing times for these jobs on machines M1 and M2, which is in hours. Now in order to sequence these jobs, we'll use the Johnson's method. Now as per Johnson's method, we have to first find out the smallest processing time on either of the machines. Now if the smallest processing time is on the first machine, then we'll schedule the job at the beginning of the sequence. However, if the smallest processing time is on the second machine, then we'll schedule the job at the end of the sequence. So let us first find out the smallest processing time. So the smallest processing time appears to be 1, which is for job C on M1, for H on M1, and for I on M2. So for C and H, the smallest processing time is on the first machine, while for I, the smallest processing time is on the second machine. So C and H have to be scheduled at the beginning of the sequence, while I has to be scheduled at the end of the sequence. However, since we have a tie between C and H, we get two combinations. One which starts with C and the other which starts with H. So if it starts with C, the second one will be H, and if it starts with H, the second will be C. And for both these sequences, the last job to be scheduled will be I. So now that we have sequenced these three jobs, let us cross them off. Now let's find out the next smallest processing time. So we have 2 for A, 2 for E. So we have a tie again, and both these are on the first machine. So there are two possible sequences again for each of these cases. So let's understand this. So we had CH and HC. Now after CH, then either we can have A and then E, or we can have E and then A. And similarly with H at the beginning, HC, again the same combination, A and E, or E and A. So this will become CH, A, E, and then we have to create another combination which says CHEA, and then HCAE, and another combination HCEA, and both of these will also have the last job as I. And now let's strike off these two jobs because we have already processed them. Now let's find out the next smallest processing time, which is 3, and that is for B and F. Now for F, it is at the first machine, which is M1, so we can process F at the beginning of the sequence, so F will come here, while B is on machine M2, so we'll sequence this from the end, so B will be here, and we can strike off both of these jobs. Now let us find out the next smallest processing time amongst the jobs which are not considered before. So 5 appears to be the next smallest, which is for G and for J. So G will be in the beginning because it is on the first machine, and J will be from the end. Let's strike these two off. And then the last remaining job is D. So D will be here. So these 4 possible sequences can give us the minimum possible time for these jobs. Now, before solving this example using the Johnson's method, we had found out, or we had tried to find out, the overall processing time if we process the jobs in the sequence given to us in the example. Now let us find out the overall processing time and the idle times using one of these sequences, and then let's compare this with that one. So let us consider this sequence. So we have jobs H, C, A, E, F, G, D, J, B, and I. Next we have M1, and we'll have in and out. Then we'll have M2, in and out. So job H takes 1 hour to be processed on M1. So it is in on the 0th instance, and it will be out after 1 hour. And it will go into M2 immediately. So it can go in at the first hour. And it takes 2 hours to be processed on M2. So it will be out on the 3rd hour. Now job C takes 1 hour to be processed on M1. so it can go in after H has been completed on M1. So first hour it can go into M1, and then it will take one more hour, so 1 plus 1 2, so it is out on the second hour. Now even though it is out on the second hour, it cannot go into M2 because H is still being processed on M2, so this can go in at the third hour. And it takes 4 hours to process C on M2, so 3 plus 4 is 7. A can go in on the second hour, and it takes 2 hours, so out on 4. Now A can go into M2 at the 7th hour, and it takes 7 hours to be processed, so it will be out on the 14th hour. Now E can go into M1 at the 4th hour, and it will be taking 2 hours on M1, so it will be out on the 6th hour. Now E can go into M2 on the 14th hour, and E takes 8 hours to be processed on M2, so it will be out on the 22nd hour. F will be into M1 at the 6th hour, and it will take 3 hours there, so it will be out at the 9th hour. Now F can go into M2 after 22nd hour, and F will take 9 hours to be processed on M2, so it will be out after 31 hours. Now G can go in to M1 at the 9th hour, and it takes 5 hours to be processed there, so 9 plus 5 is 14. And G can go into M2 at 31 hours, and it takes 10 hours to be processed on M2, so it will be out at the 41st hour. D can go in at the 14th hour, and it takes 6 hours, so it will be out on the 20th hour. Now D can go into M2 at the 41st hour, and D takes 7 hours there, so it will be out at the 48th hour. Now J can go into M1 at the 20th hour, and it takes 8 hours there, so it will be out on the 28th hour. J will then go into M2 on the 48th hour, and it takes 5 hours there, so it will be out on the 53rd hour. B will be into M1 at the 28th hour, and it takes 5 hours there, so it will be out on the 33rd hour. Now B will go into M2 at the 53rd hour, and it takes 3 hours there, so it will be out at the 56th hour. I will go into M1 at the 33rd hour, and it takes 6 hours to be processed, so it will be out on the 39th hour. Now I will go into M2 at the 56th hour, and it takes 1 hour to be processed there, so it will be out at the 57th hour. So here the total processing time is 57 hours, while the analysis that we had done by randomly choosing the sequence that was given in the example was coming out to 58 hours. So by using Johnson's method, we have definitely saved 1 hour in the overall processing by sequencing the jobs using Johnson's rule. Now let us also find out the wait time of the jobs. So H does not have to wait. C has to wait for 1 hour, which is 3 minus 2. A has to wait for 7 minus 4, which is 3 hours. E has to wait for 14 minus 6, which is 8 hours. F has to wait for 22 minus 9, which is 13 hours. G has to wait for 31 minus 14, which is 17 hours. D has to wait for 41 minus 20, which is 21 hours. J has to wait for 48 minus 28, which is 20 hours. B has to wait for 53 minus 33, which is 20 hours again. And I has to wait for 56 minus 39, which is 17 hours. Now we can also find out the idle time of machines. So for M1, basically M1 starts processing at the beginning, but it finishes processing at the 39th hour, while M2 is still processing I till the 57th hour, and the time for which it is idle is 57 minus 39, which is 18 hours. Now in case of M2, M2 is idle in the beginning when M1 is processing the first job. So M2 is idle for 1 hour in the beginning, and then if you see, it has never been idle because as soon as a job comes out, the next job goes in. So 7, 7, 14, 14, 22, 22, 31, 31, 41, 41, 48, 48, 53, 53, and 56, 56. So M2 is idle for 1 hour.